Hello and welcome back to Elementary Algebra section 2.4 on formulas. So in this section we learn about formulas. We learn what they do, how they help us in everyday dealings with not just money but also with the basic geometry, so we can do some home improvements maybe, and I don't know, whatever else. So you have dealt with formulas before. We have seen dirt, right? Before, which was this letter was a variable which stands for distance, and this was speed, and t was time. And you can use this formula to compute any of the values given you have the other two. So if I have speed and the time, I can calculate how far I go. If I have the distance and the rate, I can calculate the time, which is how long will it take me to get place. So there's a lot of cool stuff, and I believe we mentioned last time the traveling from Clinton exit 17 to our exit on 26, and calculating those 9 miles between two exits, and that it will take about 9 minutes, right, to cover those 9 miles if you go 60 miles per hour. You can do that stuff. You can do that stuff when you have formulas. There are also formulas that would convert the temperature. This is another formula that you should memorize. I believe there are 3 formulas that you have to memorize for the first exam. So dirt is one of them. Then the next formula, well, actually no, you don't need to memorize interest for this exam. It's next exam, I believe. Yeah, whatever, we'll see. So dirt is one of them. Another formula is temperature, where the Fahrenheit is equal to 9/5 Celsius plus 32. The interesting thing is that in the world, United States is the only country, and I'm not saying America, not all of the continents, including Central and South America, not even Canada. Only United States uses Fahrenheit to measure temperature. The rest of the world uses Celsius. So the conversion is important, because if you are to go anywhere out of the country and watch the news or something, and they tell you that it's going to be 28 degrees that day, are you supposed to bring the coat? Right? So to answer a question like that, because when you go anywhere out of the U.S., no one will bother to put Fahrenheits. Like, this is the only country that would list something in multiple languages and things like that, because there are no standards. Believe it or not, English is not official language of United States. Look it up. I was shocked when I when I learned that fact. Anyway, so what you do is convert the temperature, and if, let's say, you are in Italy, you went over there to take a look at all of the rubble they have, and Italy, TV, news, weather, and then they say 24, boom, like that. Now, do you bring a coat if you are going sightseeing? Well, your job is to take this 24 and plug it in there, because the temperature given is the temperature in Celsius, which is the language you don't speak. And then you can calculate the temperature in Fahrenheit, which is the temperature you do speak. So this is why formulas are important. So here we go. 9/5 times 24 plus 32. These are fractions. You can make 24 into a fraction over 1 and then just multiply across. So how much is 9 times 24? Nine times 24 is 216, yes. And then you divide that by 5. And finally, add 32. And you see that the temperature is comfortable, right? 75 degrees. No need for a coat. That 24 looked bad, right? But it's actually 75.2 in Fahrenheit. So this formula can convert either way. Now, the funny story is me moving to US when we landed. The flight attendant said the PA, and the temperature is comfortable 82 degrees. I was like, what the hell? That's hell on earth, 82 degrees. You know, when you talk Celsius, like if it's 45 outside, you're just dead. And she said 82. I said, what? No. Turn the plane around. Going back. I was ready for inches. I was ready for feet. I was ready for, you know, some of the stuff. Yeah, sure. I researched it. Never crossed my mind once to check the temperature. I freaked out. That was a genuine freak out there. Another thing, guys, traveling to a country, either Mexico or Canada, they're driving distance in some sense. But again, most of the world, vast majority of the world, maybe 3 or 4 countries exception, no one uses miles. So all meters and kilometers and the centimeters and millimeters and so on. So most likely your cars have both scales on, where the bold one with smaller numbers is miles, and usually thinner one is the with larger numbers is kilometers per hour. And you have both of those scales. So if you are to drive to Canada, you have to observe the other scale as a speedometer. So when you see, 120, don't drive 120 miles per hour. It's not the same. So the conversion factor is about 1.6, and mile is bigger. So mile is equal to 1.6 times kilometers. That's the conversion. So this is your miles. No, this is not a fun. This is just a conversion factor for fun. These are the two formulas that are there. They are. Now, this formula is one of those where if you are planning on driving anywhere, pretty much anywhere. So England has the same feet system and so on, but the rest of Europe does not. Everything is kilometers. So if you see a speed sign, and they're usually round in Europe, like this, and it says 80 on it, that 80 is 80 kilometers per hour. And yes, we are going to put that in our formula to see in miles. So it's going to be 1.6 times the amount of oh no, I have this backwards. Guys. Oops. Kilometers is equal to 1.6 miles, because miles are a smaller number. Holy nightmare. Yeah. I completely, yeah. So this is going to be 80 equals 1.6 m. There we go. So m is equal to 80 divided by 1.6. Much better. I wasn't thinking. So now you divide this value, 80 divided by 1.6, and you will get 50 miles per hour. And you will see on the speedometer in a car, right, like this, you would see that it says 50, but then it says 80 on the bottom, on the same tick mark for your speedometer for the car. So, 0 obviously matches for all of them. So you can, you'll have a couple of these tick marks that match along the way. So the top scale usually is miles per hour, and the bottom scale is kilometers per hour for as you drive. So maybe I would usually, I say to students, maybe you will pay attention when you go home after the class, but this time the class is actually at your house. Then we have a whole spiel of formulas from geometry. Whether you know these or not, that's all up to you. Geometry is very useful to figure out stuff for home improvement, as I mentioned earlier, and other stuff as well. If you want to paint the wall and you don't want to go to the place that sells paint 15,000 times because you need more, or you bought way too much or so, if you just want the perfect amount, you realize that your wall is a rectangle, and then you measure this as, 14 feet. Let's go with 18 feet. You measured on the floor 18 feet on the bottom, and let's say it's standard heights for the ceiling are 8 and 10. Let's call it 10 feet tall ceiling. You have the formula which says that the area of the rectangle is x times y. You also know it as a times b. I really don't care what letters you learned, and right, it's just you multiply two dimensions, dimension x, which is 18, and dimension y, which is 10. So area is 18 times 10, which is 180 feet square, or you know this as the SQ feet, square feet. So when you know the size of the surface you need to cover, you can go and buy exact amount of paint that you would need. Let's say you want 2 coats, right? And each paint tells you how many square feet it can cover, right? For the, so if you have, let's say you want two coats, right? Then can you buy a can that covers 300 square feet? Would that do it? If you want to put 2 coats of paint on this wall that we just calculated the area for, you go to the store and the can of paint covers 300 feet squared. Is that enough for 2 coats? No, right? It's a word problem, because 180 times 2 is 360. And if the can is covering 300, then you're 60 square feet short, which means another trip to the store. So, these kind of things, as I said, they are not something that you absolutely need to know, but the life is so much easier if you know it. It's just unbelievable. You can make your decisions about pricing and things before you even go to the store and try to make, get someone to do the estimate and so on. Because if you take a look for let's say you want to install new floor or new carpet. Well, your room is a rectangle again, most likely. And then you measure your room. Let's say it's 18 by 14. This is floor. You still have the same area for the floor, will be 18 times 14. Right? So now you're going to compute that and get 252 square feet. Then what I'm going to do now is I'm going to go to, let's go to Lowe's, I don't care, Lowe's, and then I'm going to take carpet. There we go. And indoor carpet. And it says indoor carpet. Now I'm looking for what I like. I mean, I don't like carpet, but let's say I do. And here is the carpet. It says $1.19 per square feet. So price is, this is the real price I'm looking at, $1.19 per square feet. So now I know that the cost is going to be $252. I'm sorry, 252 square feet times 1.19, right? Then we punch that in our calculator, times 1.19. There we go, and we get $299.88. Awesome. So $300 just to replace the carpet. So you can use these things to approximate and see your budget before you even go and look for estimate or anything like that. Because, guy's going to come in and going to say, okay, now you're going to have the carpet, that's $300. Then you need the thing that goes under it, some kind of, whatever that protection thingy is. Then you need those strips with nails in the corner to hold the carpet. Then you're going to need baseboard, right, for the wall, the molding that goes on the bottom. Oh, that's another formula, right? Because that's a perimeter formula. So your perimeter here is 18 plus 18 plus 14 plus 14. You can memorize that formula as 2a plus 2b for a perimeter. And you can calculate that you need, 36, 50, 64 feet of baseboard, molding, baseboard, whatever. So 64 feet of that. Most likely you're going to get 72 feet and then fit all of that in, have some extra. So you can actually figure out the cost of these things. So you have the cost for the paint and to paint the room. I did only one wall, but you can do all 4 walls. Then, right, and when you compute these things and you know in advance, right, then the prices don't surprise you. The quote is not going to surprise you because you were expecting to spend $500 to replace, right? Because we have to figure out how much is this. Usually about $1 per square foot, so it's going to be $64 there. Then those nails and things that they have, another $60 there maybe. So you're looking at $500 with, hopefully with tax, to replace the carpet for this room. You can compute all of these things if you know formulas, and those formulas are basic geometry. We already talked about fractions with pizza, right? So we know the circle, and you cut that circle into slices. You have 1/8 of a slice and 1/8 of a slice and so on. That will be when we talked fractions. But then when you take a look, right, the pizza will have its diameter, which is this line across. And then there's a radius. And then there is this line around which is called a circumference, which is going around. Then there's area of the circle. And believe it or not, for the big companies, the chain companies, maybe Pizza Hut or whatever, those chains that deal with pizzas, right, on a large scale, where they send, thousands upon thousands a day, all over the place, country and abroad probably. They actually have people that compute the cost of toppings and cheese and sauce and everything that goes on a pizza, so they can charge appropriate amount and as low as possible, so they can still make profit, so they can pay workers and facilities and everything else. You can literally figure out how much cheese you need for one pizza by calculating circumference, because if you have that cheese stuffed in a crust, that's going to go around the pizza on the other side, and that's a circumference, which is 2 times the radius times pi, and the pi is that 3.14. So if your radius of a pizza is, 4-inch radius or 8-inch radius, I don't know whatever the radius is, you can compute the distance over here, and then you can figure out how much cheese you actually need. And the stuff inside is the area, pi r squared, same pi, 3.14, r is the radius. Which is from the center to the edge. And you can compute the area of the pizza, and the surface area is how many toppings, right, go in the middle. Now, these things are actually calculated so they can have exact, right, down to the penny, exact cost to make the pizza, and then they can quickly figure out what the profit margin should be on the whole thing, add that to the price, which is the price you pay when you go to buy. So a lot of use for these formulas, and they're constantly used in various situations, triangles and trapezoid and all of this stuff. Boxes, right? Boxes. There is a whole branch of engineering called packaging engineering. These people develop boxes to ship stuff, and more. Post office, UPS, FedEx, right? All of those guys worry about their shipping and the space, conserving the space. In terms of packages, when it comes to packages, you usually, no two boxes are alike. It's just, big one is the airport, putting the luggage into the train. That's a big one as well. You play Tetris over there very well, right? To fit everything inside, and which is the reason why, right? Plus the cost of the fuel, which is the reason why when you have an extra bag, they charge you 2 gallons of blood and the unborn child for an extra bag. Well, that's actually true. That's not a joke. Yep, it's $100 minimum. It's easier to walk your luggage to your destination, come back, and then take a plane ride. It's probably cheaper to, let's say you're going to vacation to a country that it's really, really cheap. It's cheaper just to buy your stuff over there and just abandon it, leaving. If the bag is going to cost you $150 to haul your clothes, right? And then coming back, just put 6 outfits on you and and suffer on the way back. But yeah, some people actually ship through UPS and stuff. They ship their luggage to. I was laughing when I learned that one. Yeah, ship your stuff ahead of the time, and by the time you get to your hotel or whatever resort and stuff, everything is already unpacked on hangers, and you just go straight to the pool. I was like, wow, it's amazing. You still pay for it. And guys, flipping the formulas. So usually, right, you can compute the values. Dirt for speed, right? You can solve for R. When we say solve for R, I'll write this in blood, means get R by itself. So that means that your job is to divide both sides by t, because t is the one that's bothering R. And once you get t to the other side, R is alone, and there you go. You solve the equation for R. That's correct for physics, especially when you have to combine multiple formulas into one. In mathematics, if you're asked to compute a value, it's much faster for you to just plug all the numbers in and follow the rules of solving equations, right? Adding, subtracting numbers and all of that stuff. It's much faster to do it that way. Only if the problem tells you to, flip the formula around, then I would go and flip the formula around. So if you take a look at the area of a trapezoid. Trapezoid is a geometrical figure that looks like this, has A and B, and then this height h. So area of this is 1/2 A plus B times h. If they're asking me to compute A, but they give me B and h as numbers, I would plug that in and then work out calculations. But if they just say solve for A and I have no numbers given, then I would have to go and do this. So I'm going to do both of those problems now so you guys can see. So I say problem 1, given B equals 2 and h equals 4, compute. Oh, I need also area. I also need A, and capital A equals to, I don't know, 100, whatever. Calculate A, which is this side here. So what you would do is, in this case, you just plug everything in. You have 100 is equal to 1/2, and then A plus 2, and then times 4. So I would just plug everything in this case, and I would go and solve this problem, because this is the equation that we learned earlier. So we would say you can, 1/2 of 4 is 2. So we have 100 is equal to 2 times A plus 2. You can distribute, or you can divide both sides by 2. It doesn't matter which, it's better if you divide, because you work with smaller numbers rather than distributing. So then you get your 50 is equal to A plus 2, and A is equal to 48 when you subtract 2 on both sides. So if all of the numbers are given to you, it's faster if you immediately plug them in and compute, rather than flip the formula around to get A equals everything else and then plug numbers and compute. In some sense, you are doubling your work. But if the problem says, and here it is over here, problem 2, solve for a. No numbers given to you. Nothing. In that case, you have to go through algebra without computation and get a equals everything else. So solve for a, that means get a by itself. So you would start with 1/2 a plus b times h, multiplying entire equation by 2. So times 2. And that would give you 2a on the left, and on the right, the reason why I multiplied by 2 was to kill the fraction, because 1/2 times 2 is 1, or you can say 2 divided by 2 is 1, or you can say, oh, they are multiplicative inverses, therefore they multiply into 1. Whatever way, right, they will be gone. And what's left is h times a plus b. Now, it's the multiplication is commutative, so whether you're going to put a plus b times h or h times, you can flip anyway, because it's right. 2 times 3 is 6, and 3 times 2 is 6, and 2 times 3 is 6, and 3 times 2 is 6. So the order doesn't matter. So I'm still digging towards a, which means divide both sides by h to get h, to peel off that. So I'm closer to a, and I have now 2a over h is equal to a plus b. And there's only one step left. There's only one step left to get lowercase a alone. What's that step? Is this multiplication? It's addition, so what should I do? To get a alone, that's the goal. Subtract big. So a equals 2ah minus b. And here you go. A is now alone. So that's the problem of solve to get a alone. Let's do another one of these from homework. So they will have you flip these formulas in some exercises without computing. So I just want to find a problem with one of these equations for us to flip. Okay, so exercises 51 through 68 all have these type of problems, and we can literally pick any one of them. So here's 58. Maybe you can try it a little bit on your own, and then I'll kick in. So problem 58 says volume is equal to 1/3 pi r squared h. This is volume for the cone. If you ever wondered how much ice cream you can fit inside the cone, so you ate all of the ice cream that was sticking out, and now it's just flat on top. If you calculate this, if you measure the radius r, and you measure the height of the cone h, those are these two numbers, and you can calculate the volume of the ice cream that it's inside the cone. So that's one of the cool things you can do with this, if you care. I mean, if you don't care, don't worry about it. I like to annoy people with these kind of things, so I like to point these things out when I go somewhere, which is why no one ever invites me to go anywhere. Solve for h. So that's the question. Solve for h. So that means your h needs to be alone. Gotta get rid of the rest. So I'll give you about 2 minutes or so. All right. So, what would be the first step? What do you think? There are no addition anywhere in here, so we can't use subtraction. All of these are times, times, times. Okay, we can divide by, oh wait, you are solving for age. Age needs to be alone. If you divide by age, then you're going to get v over age, and then it's going to be a mess. Age needs to stay alone, so we need to get rid of the rest. So we need to get rid of this. How do we get rid of it? Well, let's do one by one. How do I get rid of the 1/3? What's opposite of 1/3? Perfect. Times it by 3. So we'll have 3v equals to pi r squared h. So that's where we start. We start there because we want to get rid of the fraction first. Now we can get rid of the pi r squared by dividing it, because pi r squared is multiplied into h. So I'm going to divide both sides by pi r squared. Those will cancel, and there it is. H is equal to 3v divided by pi r squared. I'll put this one on a cloud. Ta-da! That's it. I hope you're not disappointed. Bye.